A small ball is projected vertically upward with speed 29.4 meters per second from point A, which is 19.6 meters above the horizontal ground. Okay, we have a ball projected upward. Initial velocity equals 29.4 meters per second from point A, which is 19.6 meters above the horizontal ground. Imagine that this is our ground, and here S equals 19.6 or H equals 19.6 meters. The ball is modeled as a particle moving freely under gravity until it hits the ground. It is assumed that the ball doesn't rebound, okay? Find the distance traveled by the ball while its speed is less than 14.7 meters per second. Okay. So, uh, initial velocity is 29.4 meters per second. So after a while, the velocity will be 14.4, 14.7 meters per second. Okay, let's find the distance when velocity equals 14.7 meters per second. It means that final velocity will be 14.7 meters per second. Our initial velocity equals 29.4 meters per second. We are looking for the displacement or distance when the velocity is less than 14.7 meters per second. Okay, so we don't have time, so we have to use this formula. V power 2 equals u power 2 plus 2 multiply a multiply s. So v is 14.7 power 2 equals initial velocity 29.4 power 2 plus 2 multiply. Since we projected upward, acceleration is negative. We have decrease in velocity, so it is minus. Acceleration is minus. Multiply s. So here, if you calculate it, you will find s equals 33.1 meters. Okay, next part, find the time for which the ball is moving with a speed of more than 29.4 meters per second. Okay, so this moment is when the ball goes up and it reaches to the maximum height and then turn back toward the ground. Here, when again it reaches to same point, point A, our velocity will be 29.4, and when it passes this point, our velocity will be more than 29.4, and it will increase until it hits the ground. Okay, so we can say that using acceleration formula, we can find, okay, so we can write the acceleration formula, which is v minus u divided by t. Okay, so acceleration is minus 9.8 equals v final velocity. It will be more than 29.4 minus initial velocity is 29.4. But look, when we go upward, our velocity is 29.4. When we come again toward the ground, our velocity direction is changed to downward. It means that the sign of velocity is changed. It means that our final velocity is minus 29.4 because we change the direction. So it will be minus 29.4 minus u 29.4 divided by time. So from here you can find t equals 6 seconds. Or you can say that when you turn back to the same point, to the point A, our displacement will be 0 because we start from A and turn back again toward A. It means that there is no displacement. We are in the same point. So it means that we can say that S equals 0. Since S equals 0, from the formula S equals Vt minus 1 over 2 at power 2, we can write 0 equals V is minus 29.4 because, as I said, we are going toward ground, so our direction is changed. Multiply T plus 1 over 2 minus 9.8 multiply again power 2. So you can find T from this formula as well. So let's say T will be, one of the answers will be 0 and the other one will be 6 seconds. 0 because it is the start point in this point when we start in the point A. So t equals 0, it's correct. And when we turn back again to the same point, our time will be 6 seconds. So this one will be our answer.